Okay, let's very quickly talk about autoencoders. I'm going to show you the structure of it afterward, but for the beginning, we're just gonna see what does an autoencoder do. And in this one, I'm going to focus on dimensionality reduction, so we can compare it to PCA. Generally, the idea is the autoencoder is for nonlinear data. It can reduce the dimensions of nonlinear data, but PCA does best for linear data. And let's see what I mean by that. So when we are talking about PCA, these are my axes. I have my x-axis and I have my y-axis, okay? So for example, my data, as we said before, looks like this. So right now, I need 2 dimensions to represent this. And then if I want to use PCA, I will move my X this way. It's not going to be PCA anymore. This is CP1, and this is the right angle. This is CP2. I'm not going in depth about this because we already talked about PCA. So for example, if we have a data that looks like this is our X and Y again. If we have a data that looks like this is nonlinear, right? And we cannot move our PCs in any ways that would be able to get rid of one of the axes, one of the dimensions. Because however I change X or however I change Y, I won't be able to capture all of the variance. Like for example, these points, I don't have problems. So maybe I should do this. Like we have here and then we have here. So these two are very close, but then when you are going this way, these points are very far from each other. So there's no way that you can get rid of one of these axes here. But now let's see what autoencoder can do. So we have the same data. We have X and Y again, and we have the same data here. What autoencoder is able to do is it can bend the axis. Do you remember we talked about manifolds? That is like a shape that is folded in a higher dimension. This is going to be the same idea. Here will drop. I can get rid of Y, and then I can bend my axis this way, okay? So right now, I'm not losing any information. So right now, when we had it here, I wasn't able to see the difference, but now since my axis is bent, I can actually capture all of these information. So, and this is useful. The reason we want to bring everything to a lower dimension is because it will make our processing time lower. And so for example, if you're talking about an image with like millions of pixels, or let's talk about like 2000 pixel you have, if you have to go through each pixel individually, it's going to have a very long processing time to figure out what that picture represents. But imagine all of your data set is pictures of human. So what they do, when you're bending your axis to capture the data, instead of just looking at that pixel, you can look at multiple data sets with multiple dimensions. So for example, you can capture the features of a nose and you say, okay, all of these features together is going to be nose. All of these features together are going to be eyes. All of these features together are going to be mouth. So when you want to figure out a person in that image, now you don't have to go individually through each pixel and then see the relationship between them, and maybe you're able to capture maybe be able to understand that that's a human. With this way, it's going to be faster and easier. We're not getting rid of any of the data. All of the data is still there. We're just getting rid of our axis or our dimensions. And the reason we can do that, like we're doing the same thing with the PCA, but PCA is not able to do nonlinear. So this is why autoencoder is very useful. And then after this, I'm going to show you the structure. Autoencoders are very similar to neural networks. So we have input here, which goes to multiple layers. It can just have one, or it can have multiple. But you have an hidden layer, and then you have your bottleneck, your bottleneck have the least amount of node in it. And then again, you might have a hidden layer or you might not have a hidden layer. And then you have your output. Okay, these ones are going to be connected to each other. I'm not going to connect all of them together. I'm just going to put a picture later. So yeah, but basically that's how it works. So now let's explain each part of these autoencoder. Encoders first get the input. So this is our input. Input gets in. Okay. And then what happens, it will go through multiple layers, and each one of these layers try to figure out some patterns in our data. And then after that, you reach the bottleneck. Bottleneck have the least amount of nodes in it. And so it will try to compress everything together. And I will explain what this compressing means here. And then it will go for the decoding. So these are the layers of decoding. And then, so let's talk about what happens here. First, we have our input data coming in. We're trying to compress it as much as possible. When we compressed it, this is not the original data anymore. So this is not your input anymore. And then we are going to try to expand it to get the original input again. So we're trying to match these outputs to be the same as inputs. And again, we're going to the same structure that we explained for neural network. We identify the patterns and we are finding the most important patterns. And then after that, when you want to reconstruct it, you don't really need those extra features or patterns that were not relevant.